Hello and welcome everyone to AI Design. Thank you for Redefine Game Dev for all his work on Godot Jam. If you are here live with me, I hope you all are having a great time in the jam itself and also through the videos that are going around. If you're watching this later, do go back and watch the many videos that happened during this event. They are being very interesting, in my opinion. And yeah, this video will have a lot of interactivity, so I am in the comments. Feel free to comment down below during the video on the many little different aspects of AI that we're talking about during the video itself. As you already may know, I like doing Godot 4 preview videos, kind of, and also some smaller tutorials over Godot. My area uses a lot of AI. And also in the past, I've worked on robotics or mobile robotics to be more exact. And this is the kind of idea that I will bring to the table. This way of viewing and understanding AI, especially in games, is not exactly the best necessarily. It's just one of them. But I'll present the way that I see it. In mobile robotics or robotics controlled by AI, not just pure autonomous robotics, we have the idea that essentially the robot is in a world or in an environment somewhere. It senses something from the environment. With whatever it senses, it decides something to do, depending on whatever logic you're expecting from the robot. And on top of that, the robot acts on top of the world or environment. The world itself can be like any environment, can be in a simulated sense, can be like a game, obviously, or also in the real world, imagine say Tesla or some robotic car, it will be the streets or whatever else, depending on what the environment of the robot is. Sensing part is exactly what it sounds like. Whatever sensors or whatever knowledge the robot or this agent can retrieve from the world. For example, in the streets, a car, an autonomous vehicle like a Tesla can have a radar sensor. So this is just one example, and we'll talk about examples in games shortly. From this, imagine the car wants to drive itself. So the decision can be something like, should I stop? Maybe the radar sensor finds someone standing on the road just in front of the car. So the robot car should decide whether it should brake or not. And after braking, say this is what it decided, how do I act on top of the world? So the act uses some kind of actuator, which can be, for example, brakes or robotic brakes, so to speak, because the robot needs to have access to that actuator. And this is like the essence of AI robotics. I'll even put AI robotics here. And by the way, if you're wondering what is this, I'll put my link below. There's like a tutorial that I made on building a mind map using Godot. Yes, this is Godot. You can just follow the tutorial and build this for your own so that you can use for either explanations or keeping notes or whatever. I will use this framework throughout the rest of the video. This video is both targeted to like early game developers or hobbyists, which want to understand a little bit better what type of mindset and design methodology can be applied to AI design, and also more experienced game developers who can use this framework. It's a way to aggregate a little bit more information so that you, the game developer, can make thoughtful decisions regarding what are the AI agents in your game and also what the AI agents do in the game itself. In games, different from real world, the environment will change as well. Normally, the environment is just one thing. For example, I said about the autonomous vehicles, Tesla of the world. Obviously, Teslas can only drive in the road, so the Tesla can't necessarily know what's inside, let's say, a building nearby, not by itself. But in a game, if the vehicle is like a car, also in a game, obviously you can provide the information to the car of whatever else you want. So although mobile robotics don't take care much of the world part, in games, it's something that will end up also needing to keep track and decide what is the world or what is the game or what in a game your AI is doing and I'll give some examples shortly. What in this world or this environment the AI agent can see and can fetch information from, what it should do with information, how does it do the thing, and go back to the world, say update. This is like an update process essentially, where you change the world because you moved or something like that, and you read again. Here I have some like random, it's literally random examples. You can see here I just Googled games. And this exercise I'll do like I would do for my own, instead of like being fancy with a video, just so that you can do it for your own in the same way. I just searched games. First thing that appeared, this is Minecraft, right? Obviously there is myself, but think about it. In Minecraft, there are many other different AI agents, from NPCs, enemies, little just random animals that run around and you want to get meat from them or whatever. What do they do? What is the environment they are in? What is the sensors, or what kind of information do they retrieve from the environment, and so on and so forth. So bad I don't have Minecraft to open and show the things, but I'll ask you to imagine. Say there's like, I'm walking around and I see a pig. Say I am here, I am like some mesh thingy. So here I am, I need to rotate myself. And nearby me, there's also the pig. So there's a pig here, I'll call it pig. I am for sure taller, so I'll do some small modifications just for explanation's sake. So I have the pig here in orange and myself in red. Say I'm walking around, the pig is nearby, like just walking. If you think about what happens in the game, the pig first is walking somehow. So there's some already thing going on. If it gets near me, it like essentially sees that I am there, and maybe it just continues. If I hit him, he knows where I'm at, he flees from me. This is the logic behind the scenes, or something like that. I mean, like, I didn't play Minecraft that much, so maybe a little bit wrong, but you get the point. Let's think about just roaming around. Roaming around is a problem on navigation, right? It's just trying to get around things. There's a map. You need to find, in a sense, where the ground is and where you should go. There are many little different logics that can control a good roaming behavior of a pig, since you don't expect a pig to like jump 100 meters in the air and go to the top of the mountain with a jump. Like, this is not a normal behavior, not for a pig at least. But the problem is there. What is the world? Of course, it's the terrain. What is the sensor? I'll leave it open here. So what is the world? Is the terrain environment, essentially. What is the pig sensing at first? When it's roaming around, does it actually senses anything? Not exactly. At most, it just knows where the ground is, or maybe what is like right to left compared to up to down. So it has some kind of like axis knowledge. Is it deciding anything? Probably the decision like walk to some random direction or something like that. And the action is literally walking. So I'll even say here, world can be a terrain. Sensing can be, say, axis or direction. What is it deciding? Random direction to move. And how is it acting? It's just moving. I'll zoom in so that everyone can see with not much of a problem. Here's a very basic logic of my pig, split up by this AI robotics, and I'll rename this to AI agent, just because we are tackling agents now. A single AI agent of this pig is doing this logic. And this is why I call what I call a very simple agent. I have like at least in my mind, some small differentiations of what are the styles of agents. And this is what we are going to talk about now, to not just see what the AI is doing, but what is its goal. If you get both of these ideas together, you can essentially create any kind of AI. Of course, if you can just come up on the spot of a random AI idea, that's great. But with this methodology, this will help you understand what you're doing. The pig is already a complex example. So let's go back to Google and keep looking and thinking about other examples. I have one in mind. Let me see if anything happens to appear here. Recently, I played Donkey Kong Country once again with my wife, and we got to like fight these many little bad guys from Donkey Kong Country. It is a retro game, so to speak, because it's old, right? And let's think about what these enemies do. Let's start with the bee. If you remember how Donkey Kong Country works, it's a 2D platformer, as many of you may be doing for the jam. And the enemies has different AI logic. Let's think about the bee. If you remember, bee is a kind of enemy where anywhere that it touches, if the Kongs touch the bee, the Kongs essentially die. But what do the bee do? Usually the bee has no concept at all of the world because it doesn't care about what's going on. Usually there's no sensor at all as well. Does it decide to do anything? Most of the bees are just stopped in a place, and it's like you need to go around the bee somehow, so it doesn't decide anything. And it barely acts, if at all. So this is the logic of the AI agent bee. I guess this bee is pretty stupid, or like it literally doesn't do anything. And yes, you can consider this an AI agent merely because it is like a enemy. It can aggregate information after, but this is the first type of agent or of AI that I'll talk about. So AI agent types, maybe. The first one is like nothing. An AI that literally does nothing. Second type is what I usually put something in act. Sometimes it doesn't care about the world, it doesn't care about what is around itself. It's not deciding anything, it's just following a path. The same bee sometimes also follows a path in the environment. So I'll just create a new 2D scene here and drag some icons, are faithful with icons. One of them I'll change. Okay, so the enemy sometimes is alone and stopped. And if I create, say, a tile map, maybe it's something like this. This is the bee. This is me. And say I am over here and the bee is over here. I'm just walking, I jump. And this bee can just literally be going up and down here, or some other enemy, which essentially blocks the path. And I want to pass underneath it while it's above. This type of AI, what I call, is constant AI. This AI only does something, but it doesn't care about what's happening around it. There's no decision being made. There's no sensors, and I'll talk about sensors shortly. What type of actuators can I have? And most of them, if you think about it, is regarding movement. So let's get into what Godot can help us to handle that. Constant AIs, what I suggest you to try to use is path. Not patch, path. So there's a 2D and 3D versions. In the path 2D, I'm able to say, I want this AI to be between here and here. I can see like the path going. I also just want 2 points. There we go. So just literally 2 points. And even without code, I can use animations to handle this. So let me exemplify this to you. And here's like a simple path movement using only animations. I use no code. Thank you for, I think it was Lucifer that talked about this little quirk. I watched his video some time ago. And I can come to transform. Here we go. And make it exactly follow the path. How did I do this? And this is literally a very simple process of doing simple path navigation. This is, once again, only for the acting of simple path without any sensor. But okay, what I did, I created a path 2D where I can now specify what is the path that I want this thing to follow. You can see here, I have a path, and my plan is to have something follow this path. So there's another node called path follow 2D. There's the equivalent for the 3D. On top of this, say my B is, I want it to follow the path. There's some more things that I can do here, whether I want to interpolate, whether I want to loop, etc. And the path will allow me to use this offset or unit offset for my more precise control of where I am in my path. There's other ways of doing. I suggest you to take a look on this in specific later if you are interested. And you can see now through code, I can use this to go back and forth. But what I did is I created an animation player to handle the offset, or it could be also the unit offset, one of the two, of type Bezier. I just came here and click this thing, use Bezier, it will appear here. And then by clicking here, I can see the curve itself and I can edit. I essentially gave here, say, 5 seconds. I made it start with 0, go to around 300. If it was unit offset, will go up to 1 and go back. That's all. Simple stuff. Good enough for something going up and down in a path. Now, another logic of the B is whether or not the player hits the B. So this, of course, you probably already know. You create, can be an area 2D or something similar with a collision shape. And the collision shape can be, I don't know, a circle. It's good enough. Stop, please. I want to fetch this. And now there's some kind of thing that you can do, whether I hit this collision, I die, or something similar. But still, you'll notice that the B itself is not tracking me to like shoot me or something. This type of AI, which I call constant, is very good for simple games and retro games, as we see here. I also see them a lot in, say, puzzle games. Even Donkey Kong Country is kind of a puzzle game, more or less. Just because of what you do in the levels, you literally go forward trying not to hit the enemies and killing some of them. There are some enemies with more logic, but most of them are like very simple logic. Even bosses like are constant logics like this. Think about bosses even. If your boss follows a predefined order of attacks without caring what's around it or where the player is or anything, this boss is a constant AI boss. These names I myself gave, but it represents well the different styles of AI that you'll find around. Yeah, let me know also in the chat if you know, if you can think of other nothing or constant AIs. Like myself, I can say of nothing, maybe the ground. The ground doesn't move and does nothing. Technically it could. Therefore, it's a nothing AI agent or absence of AI that you can also see like this. Another type of constant. I talk about navigation, but of course, not everything is navigation. Maybe you have another, come back here. Say this is not a pig, this is an NPC which sells weapons. Does it actually do anything? Like it doesn't move, correct? And there's just an NPC here with some kind of, I should definitely make some CSG shapes here to be fancy. And this is the NPC seller selling something here in his little stand. Does the NPC do anything? No, but you can go there and talk with him. Like if you talk with him, he will tell you a pre-described set of information and sell you a pre-described set of weapons. Therefore, constant AI. It's like pre-described things. It's not doing nothing, like it's doing something. But like simple stuff, right? Now think about it. The next one will involve some kind of decision. So in a decider AI, there's some kind of decision going on, even though it doesn't know anything. But say this little shop here. Can I stop fetching it? Okay. So now I can't select it. Say this NPC is selling weapons, but randomly it changes. It changes from guns, I don't know, guns. But then randomly can change to just shields. If it changes, just think about this process. And now, hopefully now you can start understanding a little bit better the advantage of seeing things with this mindset. You can grow the capabilities of literally anything in your game by expanding it using this. Like I had a constant NPC, now I have a decider NPC because there's some decision going on, even though like it can't sense anything yet, but it does decide whether randomly to give you a weapon or a shield. maybe now this is not an NPC. This is literally a little, I'll bring this here. This is like a shrine or something in a dungeon crawler. Where's me? Yeah. I finally got there. Here. I got to this shrine and I got like a secret chest. Is the chest always the same? Constant? Is the chest random? Decider? Is the chest going to sense something before deciding? So in the purpose AI, the AI actually senses, so say it senses my level. And depending on the level, I give a gun or shield. Or depending on the level, I give like a higher level gun. Or something like this. Of course, it can still follow a path at the same time. But sure, it can also be like the dialogue is constant still. We can still sense something and act in a constant way, but the decision still may depend on some kind of sensor. The sensor can have many different styles, and both actuators, and I'll call this actuator, and sense will be the sensor. To now follow the actual names, if you go to the internet, this is what you'll find. So sure, the sensor can have many different styles, not just the region. It can be something regarding the player. It can be something regarding items. It can be like, what is the world? What information are you passing so that the sensor can see? Is it the, say, player? Is it the terrain? Is it the, like, what? And this is what you decide how intelligent you want your agent to be. Finally, I'll get to the next level of AI, which I call just intelligent. And this intelligent AI now has another level, which is a full-fledged 4-step process, where the action that it takes changes what it senses as well. So in the previous purpose, I was sensing what is the player level. I get the player level. Higher level, I give a higher gun, and lower level, I give a lower level gun, and I act depending on that. However, giving a higher level gun won't increase the player's level, right? So this actuator won't change this world. This is what is happening in the purpose AI, or the level 4 AI. This level, which I won't be able to do that again, I'll just do it like this. And I don't understand why this is a problem. The intelligent AI will make an action which will change the world. Going back here, what is an action that can change the world? Give me some examples in the chat there if you have something in mind already. But here is a simple example. Say I am in a large battle with, I'll create this again, but scale it a bunch and just use normal scale. Scale. Now this is my great boss battle, which not just impacts me, but the boss follows me while I'm like going away. So you can already see here, the world is like player and terrain. My sensor, I know the player position. I decide how to get to the player. My action is like follow player. If I follow the player, nothing is happening in the world, right? Well, if I'm following the player, then the player will run away. So if the player is running away, kind of this player position is changing depending on me following the player. So yes, it's already kind of an intelligent system. But say I also am strong enough to break the terrain. So now I also break the terrain somehow. If I'm breaking the terrain, I change the terrain. I also need to sense the terrain to be able to calculate how to get to the player, right? I need to, I don't teleport there. I go walking in the terrain. So now you have an intelligent AI. And this intelligent AI style is what I usually, like, it's more rare to see. Usually what I see in games is the purpose AI, which it by itself doesn't change the world. But now you have this, now with this framework, maybe you can have, or you can think about more intelligent things or interesting systems for your game that you're building for Godot Jam. Maybe you know Jonas Troiler, who is making a game, or already made, I forget now, a game where there's an AI which follows the player. And the game is called Will You Snail. This little game here. If you think about what this game is, let me see if here it is. It is a 2D platformer, which you like just jump around and stuff. And there's an AI agent who follows you and essentially decides, I'll even get back my little thing. Where's my little thing? Decides something depending on the player position. And of course, it needs to know where the terrain is. Maybe the decision of that, his AI, is where to place a trap. It literally places a trap around where the player is. The player it also follows the player around, but this following is not using the terrain. It doesn't do this, but creates traps. After creating the trap, the terrain changes. It doesn't need to know the terrain exactly, but the player itself uses the terrain to change its position. So you already can see this AI of his game, Will You Snail, is an intelligent AI because it's literally doing the 4 types of things while the player is trying to say flee the traps that it's saying. Also, and to me it's even more interesting, this part more than the trap part, is that this AI will also talk things depending on what you're doing. So the world is also the player, but not just position, but also behavior. Essentially following the player behavior, it gets the behavior. I'll just copy paste this. It gets the behavior and decides what to say to taunt the player as well, right? And the actuator are taunts. Essentially create some taunts to change once again what the player is, or just making more interactive the process. And you can notice a nothing AI is like a rock, like it does nothing. A constant AI looks more like a little environment hazard. Now the decider AI gives a little bit more of interactivity within your game, because now things are happening depending on other things. For example, your level will decide whether a trap will activate or not. A purpose AI will now give a sense that there's someone else in the game aside from you. This is level 4 AI, where, once again, I talked about the purpose AI, where the NPC decides what to sell depending on level and talks different things. It just doesn't change the world. I talked about the boss as well. And the boss seems like a separate entity when it has purpose. An intelligent AI gets to the point of being almost a partner with you in the game. A level 6 AI is a player AI. What is a player AI? A player AI is an AI that is able to do exactly the same things as the player. So now everything here will be a lot of things. So world may be everything that the player can see, or even more. Sensor is, once again, everything the player can sense, or even more. Everything the player can decide, but not more. And this is important. And everything the player can act, and not more. These two are even more. It's just because sometimes this type of AI is just very hard to do well. So much so that what people do in the industry is to give the AI agent even more information about the world, or even like some cheat level stuff, so that the AI can handle playing against the player. And probably the most famous example of this is strategy games, say Age of Empires. Think about it. In Age of Empires, you can play against like someone else, against another player. Or if you know StarCraft, same thing. And yeah, recently there's like Age of Empires 4 came out. You can, for example, control where the scout is. And you click the scout to go over there. It needs to find the path to go over there. So think about it. This is already an AI agent. The scout itself has an AI agent where you need to find the path to the goal. What is a sensor? Terrain. Decide path. Actuator, walk. or run. Maybe even you could even decide whether to walk or run. This is an addition, but this is not done in Age of Empires. And world is terrain also. Maybe it's also like, if you want a more intelligent AI, maybe you can add sensors of enemy, and then your scout is automatically able to find paths which like goes around enemies and doesn't hit enemies. But this is, once again, additions that you can do on top of the AI agent while you're designing it. And I highly suggest you to design like this. This is how it's done in robotics space, at least. And of course, this AI itself is a purpose AI because it follows this, this, and this. It doesn't change the world by walking. But what is a player AI? Yeah, you can also play against another player or against a bot, right? And this bot can do everything that you can, which means that the bot or this AI is a player AI. Is literally some other entity which has the same amount of power and influence over the game as you do. Most, if not all, of the strategy games around has a player AI. Well, if you are able to play against a bot, that's a player AI. And this is very different from, say, RPG. In an RPG, there's no player AI because there's no one else that has the exact same amount of power and influence over the world in the game as you do. Maybe there's even more, which is the 7th level, not 4th, 7th, which I just summarize as Skynet. Maybe there's an AI that has even more power than you, but it's very rare to see games going towards the 7th level, the Skynet level of AI, where essentially the AI may have power over the game itself. Maybe the AI can literally code more game while you're playing. I don't think I've ever saw a game like this, but it will be pretty interesting. But most of the strategy games will have a player AI. And each player AI is, once important, now go back to what an agent is. Agent is the one specific logic of AI. It's totally possible, even likely, that you'll have many different agents of AI, which is now a good segue for the next thing to consider, which is AI granularity. And this is a very simple concept, is whether your AI are separate, whether they cooperate in some way, or whether they are like a swarm. Simple stuff. Separate, like each AI has absolutely no influence to other AIs. If you go back to the Donkey Kong example on the bee, and even other of the enemies, like they don't care about where the other is. They don't cooperate in any way, shape, or form. Here, if you ask two villagers to collect food or something like this, or StarCraft to collect resources, same thing. One AI has no clue or no care at all on whether another AI is doing something between the two villagers or two like resource gatherers. Well, same thing, they are separate. The AI player against you in a game like this, in a strategy game like this, will cooperate with the inner AIs, which are coordinating maybe the villagers. So the villager AI will go and collect food, and there is a player level AI which decides where the villagers need to go. So you have two AIs, in a sense, playing against you, but one of them is cooperating with the other. Swarm is very rare. It's mostly used in intelligent systems outside games. The concept behind Swarm AI is that you have a literal swarm of simple AIs which gives you a more complex behavior. You can imagine, for example, ant hive. A simple ant, all it does is like get food and bring to the hive. That's all. And the way it paths is literally go around in random until it finds something and then follows the path of its own pheromone to go back to its nest. But then how the pheromone, if you go to biology and understand how the ants do things, the pheromone it uses when coming back from a successful finding of food will put a different or a more potent pheromone in the same path, which will attract other ants to go to the same place. This is a swarm AI because they are not necessarily cooperating directly. They are at the same level, essentially, kind of separate, but there are so many of them, and there are little quirks that makes them essentially boost the level of the AI doing things, from, say, purpose to intelligence or something like that. So this is something to keep in mind, but it's not that important. And finally, my little critique and what I see of things going on in the internet of trying to explain AI, people focus totally on the AI techniques and not the AI design. This is the design. Techniques is what you do on top of it. And I'll talk a little bit, not much, about the techniques, and you can go use the information from this video to find other videos regarding the specific technique you want to apply. But to understand how to decide what technique you want, it's important to get another concept, which is, I talked about granularity. Now I will add logic. The concept of AI logic is fascinating, in my opinion. It's probably the one that makes me love AI. And I won't go too much into depth, but the reason I gave the simple version of the framework first, and maybe you're in the very beginning were like, oh, but I can make a multi-level AI and do other things. Well, I needed to start somewhere, right? Now I get to the more complex thing, which is AI logic, where you can mix and match different functionalities. Each logic corresponds to a different behavior of the AI. Each logic is one of these agent types. Maybe you have an NPC, and like I miss so much this in games. There are games that uses this. Most of games uses a little bit of this, but it seems they have no concept of the basic and the advanced separately to like bring the best out of this. I never updated this example thing, right? But what do I mean by the AI logic being more simple and more complex? Well, maybe you've heard about state machines, which is something like this, or behavior trees, which is something like this. These two structures help you organize and overlap different AI logics on top of each other so that one agent, or say one NPC, one enemy, can have multiple agent logics or can follow different agent types even. Say, for example, my enemy does nothing at all, but once a player gets near it, it becomes a constant, it starts moving. Or maybe my enemy is moving constantly, following a path. And if player comes near it, it becomes a decider. Oh, I saw a player, it's a player with a higher level, I need to flee. Or the player is a lower level, I need to attack it, or something like this. If we go back to the very first example we had of the pig, and I already lost the pig here, so I'll just make another pig and I'll reduce its size. So finicky. There we go. So this is the pig. The pig is walking around. So it's like a decider AI because it's using information of the terrain and deciding, okay, I want to go to the north a little bit randomly, and I want to go to the west a little bit. And since there is a path thing going on that we'll talk about at the end of the video, it's a decider AI. But then it gets near the player. Does it become a purpose AI? Yes, because now I will do something with a purpose. And the purpose may be the player hit me, I'm bleeding, I need to flee. So I now have another sensor, a new sensor of where the player is. I draw a path going like trying to flee the player, and I just flee the player. Maybe not very much. Maybe there's another layer of AI logic, which I flee for 10 meters and then I lose interest and start roaming again and go back to a decider AI. This is AI logic. It's like jumping around AI agent types. Usually it involves jumping around, but not always. And jumping around what is in these boxes here? What is in the world? What is in the sensor, decider, actuator? What is what I want to do with the AI? And this is where the first of the two structures come in, behavior tree. If you want to use behavior tree in Godot, I highly suggest you to come here in the asset lib and search for behavior tree. There are some plugins. Did I write it wrong? Okay. I've used this one before. I know it's fairly good. I've tried this one before. I know it works. I never used this one, so I don't know, nor this one, so I don't know as well, nor this one. But these two, I know it works well. And the idea behind the behavior tree, and there are many examples and tutorials in the internet, so I won't go into detail. But the important thing about behavior trees is that the tree gives you a hierarchical implementation of the happenings on top of these 4 boxes and deciding whether to move, say, from decider to purpose. If your AI involves, if the player is near me, do something else, then use a behavior tree. This is my point. And how to do it? Yeah, I'll ask you, everyone that knows about behavior tree, leave your comment there in the chat. I may get one of the comments or 2 or 3. If you yourself made a video of behavior tree, I'll include it in my description below as well. So this is the idea behind behavior tree, trying to change what is happening. Let's think about an example. I have a boss. In my boss, I have, so I know where the player is, decide like where to go, and I go to the player. So I know the player, the sensor is the player position. But then if the player position is near, I do something else. I'll just do this. If player is near, so if the player is near, then I do something else. Instead of deciding this, I decide to hit the player. I also decide how to hit. So maybe there are some different animations of how to hit the player. And from the decision itself, I go to the actuator, a new actuator, which is hitting the player, and go back to the world. So you can see here, this if, which jumps to this separate logic of actuator, decide, actuator, world, so on and so forth, goes through a behavior tree. You can imagine this like underneath the main one. And the behavior tree will give you the possibility of doing this if things on top of this logic that you're building. The other AI logic is state machines. It's important to know that they are kind of similar, these two. Be very careful not to try to make a state machine in a behavior tree or a behavior tree in a state machine. There's a great GDC video, this one, AI Arborist, which talked about the differences between behavior trees and state machines, how very experienced programmers and AI designers worked to solve the several problems with these two things going on at the same time. What I suggest you is use behavior tree to do this, what I just said, this if you want this if. Use state machines if there's no if. In a sense, in case you want your AI to have 2 different behaviors which coexist but are not dependent on each other, then you use state machines. Here's an example. Say I have, here's an example. Say I go back to this 2D. I have this B, which is like following a path, and randomly, or given some information of the sensor, I want to stop following this path and follow another path. So I change the path to go from the same position to the left. First randomly. Imagine this is like literally random. So how do I switch this? And now I want to change my direction, the path that I'm following, to this separate path randomly. If it's random, of course there's an if in the middle. But where is the if? Is it in the sensor? Maybe it's even in the sensor. I sensed something that made me change the path. Sure. But the point is, this separate path is not dependent on the first path. And this is the most important thing. If I sense, say, the player coming up here, and by sensing this, I change from this path to that path, I can use a state machine where one state is following one path, the second state is following the second path. By the way, there are some state machines here also. I've used this one, it's interesting, and this one, though I couldn't make it work well. But in my experience, state machines are easier to just make yourself. I have even a video talking about state machines in Godot 4. I think it would be even easier to use state machines there. But yeah, if you prefer to use an add-on, feel free to use one of these. I know Snowpack, maybe this one is good, but I never tried. I do wonder. I want to actually try it out. But yeah, if you want to change the logic without depending on an inner decision making, then sure. Let's go back to the boss example. In my boss example, I found the player and went to a different decision because now I'm near the player. I need to hit the player instead of following the player. This is not good to do with a state machine. The state machine will help you, for example, I'm following the player with one animation and I want to follow now the player with another animation. The second animation is not depending on the first one. Like the logic behind the animations do not depend on each other. Then use state machines. Great. If the second animation is better for, say, when I'm close to the player and the other farther from the player, use a behavior tree. Because you're changing the behavior in a tree structure, right? You first check if the player is near. So this would be like the topmost thing, player is near. And if it's near, say this is yes and this is no. If yes, then hit. So this would go this way. If no, then follow. This is a tree. Just look, it's a tree. Don't make a state machine with this. This is not a state machine. This is a tree. Use a tree. However, if you ignore this and you literally just want sometimes follow, sometimes hit, it doesn't depend on anything, then use a state machine. Because like you're walking maybe randomly and you try to hit the ground randomly. So you randomly go from one to the other. Yes, this is a state machine. Prefer to use a state machine here rather than a behavior tree. Of course, you can make a state machine in a behavior tree. You can make a behavior tree in a state machine. Watch this video to see why it's a bad idea. And with this, we finalize all the different concepts we need to know to design a good AI logic and good AI agents for our games. Now, what I suggest you to do with this information, go through and think about the games you like. Say in chat the game you like. Think about one of the many AI agents in the game. Tell me what type of AI agent type it is. Is it like separate from everything else? Is it cooperating with some other AI? Is it following a tree structure of logic? Or is it like following a state machine style logic? Now let's go a little bit before I finish this video to practice in Godot. I don't have time to implement every single thing here for you, but I want to give you some interesting examples of the different agent types, the different granularities, different logics, so on and so forth. Maybe you know machine learning, for example. Machine learning. Even though machine learning is like a super popular thing going on, machine learning is just one of the many techniques being used within AI design. Data science, for example, and I'm giving a lecture in data science. Machine learning is the modeling part in the middle of data. Machine learning is in the middle, like modeling. And after that, there's still evaluation. This is not a simple process. It's like much more complex. And usually what happens is something like this. You take much more time in the data, like much more time in the data, understanding the data, pre-processing the data, and so on and so forth. a little bit in machine learning, and then evaluate your results. And this is what happens also in AI designing games. You think about things and design things much more than actually needing to implement. So the code behind behavior trees and state machines, if the code is supposed to be big, then the design should be like 3 times bigger. While you think about these informations, what exactly does the AI need to sense? What exactly does it need to actuate? Does it match the pace and the purpose of the game? Do you have like a Tetris game where the AI, which keeps like dropping the pieces, is it constant, like following a predefined idea or random idea? Is it depends on what type of pieces is already down? Does it have a purpose because I need to level up the player and this gives me the information on what to give the player? Is it like intelligent with trying to trick the player or something like that? Is it playing with the player? Maybe I'm playing against a bot that is also playing Tetris. Is it Skynet, which is like morphing what the pieces can be, changing my place in the world, and like it has even more power than me, like changes where the pieces that I already put changes to something else? What is the AI in your game? Different AIs will give you different games. So be careful with that. So now let's go a little bit in techniques. One of the possible sensor we talked about a lot is player position. How to detect positions. Very easy. If you're talking about, is it close to me or not? Area. And use collision. Use the physics for your advantage. If you want literal distances, I suggest you to use some code-based thing. You can extend this. You can export a node path of, say, the player. Can be the player. Export node path. Great. Okay, so now I can see the player here. I select what is the player. And then within the code, I can follow and keep track of what is the distance to the player of myself. Now, say instead of doing this, I have a script which keeps track of many different objects and not just one. Say this is the bee. Once again, remember the bee. This is a giant bee. Maybe this is B2. Question to you. Make a script here and a script here. Each one has its own logic to keep track of the distance to the player. Then each one is separate. Do you have, say, a node outside which has like an AI script? And this AI knows the bees because I do something like this. I put all the bees inside this thing, and this AI has the information of what all the bees are doing, and it decides what to do. Then suddenly I have only one agent, and this one agent controls multiple objects. This is a different logic. This is a different game. But with this, you can decide what to do in your game. Do you prefer a swarm-based technique where each one has its own script? So go back here, swarm. Or do you want maybe Skynet version of a single AI which controls all the different pieces in the game at the same time? The code will change and the logic will change. Whether you use behavior trees, state machines, or nothing will change depending on that decision. I highly suggest you to prefer the swarm version because it always gives you less code. You need to think about it more carefully, but it always gives you less code in the swarm technique. Other techniques to apply. I talked about player position. Now let's say where to go in the decision. How to calculate paths. In 3D and 2D, there are the navigation nodes. Maybe you know. If you don't know, yeah, there are many tutorials in the internet. I suggest you to take a look on these nodes here to know how to navigate properly in a map. But this is like the complex way. There's a simpler way, which is literally, say I have this bee, I have the player. Let me get this thing We give this to the B. Now it makes more sense. And the B is following the player. Since I know where the player is, of course I can just, in my process function, I can get the node player, can get the position, the global position maybe, to be sure. I can get the global translation here, global transform. Global transform, if I have the global transform, I know where to go, and I can do movement towards it. And do some mathematics on top of this, move toward, for example. One of many examples, and you just need to add from to delta. This is another way to move towards a thing. If this is not a mesh instance, this could be a kinematic body, for example. If I am a kinematic body, I need to change this as well. I have the move and slide, or move and collide, which will help you with collisions if you have collisions. Maybe you don't have collisions, that depends on your data. Maybe you are a rigid body, same thing applies. There is in a rigid body, there's no move and collide or move and slide. You need to apply impulse or torque to go towards whatever you want to go. But technically here, using these examples, I can go towards the player. It's still ways to go towards the player. I don't necessarily need to use the navigation mesh all the time. Or this is like simple. Navigation mesh is more complex. Maybe one game that I'm playing recently is called Transit Fever. This game here, where I plan out the many trails of train tracks around the world. So the trains need necessarily to follow the tracks, but it needs to decide which track to follow. Navigation mesh won't give you enough information to do something like this, to plan out trains or plan out within a city where does the car need to go towards and which intersections to follow for the minimum path. For that, you'll need to use a more lower level A-star algorithm. So there's the A-star and A-star 2D. Usually the 2D is enough. You need to set up the things manually, but yeah, this is great. There's an advanced version of A-star called D-star, which is not implemented here, but it's all very much used in robotics as well. This is a movement, and everything here can apply to movement itself. Nothing movement, constant moving on a path, decider moving, so one of the intelligent using A-star, for example. Player movement, which is like, say in CSGO, the bot needs also to move just as the player. Navigation mesh is good for this. And Skynet, it will depend on your game. Other than movement, dialogue. If you don't know, Dialogic is a great thing to use for dialogues. Do take a look. Everything here can be made to follow the nothing for sure and follow the constant for sure, and also following the decider, because you can specify if then else's and read information from the player. But since it's extensible, you can also extend to the other four by simply reading information from other scripts in your game. So for dialogue, if you need to decide what to say depending on state machines even, yes, follow the dialogic path and search for tutorials on dialogic. Animations is another example that I gave. Decide which animation to use. For this, I highly suggest one of these two being done inside a animation tree like this. Animation tree is very powerful. Take a look on tutorials regarding animation tree. There are many of them. I already use most of them for my own purpose. I like all of them. The state machine is here in case you like using state machines. And yeah, you can make one go into the other and make the other go back to the one in a dynamic way. But not just this, you can have like the blend tree will help you with movement. The blends will help you with movement. For example, the blend tree will help you with everything else. It's the one that I most use. And the state machine, once again, blend tree is more like the behavior tree. State machine is more like the state machine itself. They are kind of similar, but use the same thing that I said. Focus on tree behavior on the blend tree, focus the state machine behavior when they are separate and do not depend on each other. So most of the time you'll end up using the blend tree. Finally, one concept that is usually misrepresented in AI design is machine learning itself. And I'll talk about machine learning to end up this video. Let me know in the comments if you know about machine learning, if you're using machine learning as this. But you'll notice that most machine learning videos uses what is called, I'll just call it deep learning, for the purpose of player-based or Skynet-based, but usually player-based AI agents. The deep learning technique usually used is called reinforcement learning. Feel free to search in Google, search other videos after this one, and you'll see most of the people uses reinforcement learning to try to replicate a player behavior in a game. And that's like 95% of all machine learning applications that I see in videos in games. But in the games themselves, I see many other applications being done, but with much less light being given to them. You see, another example of player-based machine learning is I forget which game it was. I think it was Forza, which essentially makes a bot out of your own behavior. I don't remember if it's Forza. It's one of the famous racing games. But once again, it's focusing on the player. However, machine learning is, I'll simplify this. Deep learning is just like a very advanced version of machine learning. There are many others before that. And the purpose of machine learning is, hey computer, do this that I am doing because I am too lazy to implement the logic for you. This is machine learning. I am too lazy to implement the logic by hand. Therefore, I want the machine itself to learn the logic without me needing to implement it. This is machine learning. This is all that is. A regression-based machine learning is a very simple application where I have points. Here's a 2D point. And the machine learning model essentially creates a line out of these points. Yes, this is machine learning. And it's simple. It's like just get the average of everything and you end up with a line essentially. You can measure how bad the line is, how good the line is. Does it properly follow bad, something like this, which is bad, or something like this, which is good, how to evaluate, etc. There are many techniques applied to this to understand how well the line applies to the problem. And this by itself is already machine learning called linear models. There's another very simple called KNN, which is literally, let's see if I get a good visualization. Yeah, you have some data, some information, and I'll talk about what information that can be. But you have some information. You get a new information which you don't know what the class is or what it is. You don't know this new data where it should be classified as. You just get what is nearest to, like it's nearest to this one, to the star, red star one. Then it's a red star. Yeah, that's KNN. And that's all. And this is machine learning already. So yeah, machine learning is simple. There is advanced versions which uses deep learning and uses like very advanced techniques. You don't need to use that to use machine learning in your game. You can use machine learning in your game. I plan to talk about this in a future video. I even have a simple, let me give a teaser to you if you're still here until this time. Here, machine learning, I have an implementation of a decision tree. It's a tree-based decision thing, which is like if yes and if yes, do this. If yes and if no, do this. If no and yes, do this. If no and no, do this. This is a tree-based decision tree. I have a simple implementation of decision tree here. I also have, it's not here, but I have an example working using C# and a machine learning library using other more like intermediate versions of machine learning that can be used in games and not just in games, but in development as tools for you to make your life better. Where do I use machine learning in games other than the reinforcement learning here? Reinforcement learning replaces the player logic. However, nothing logic needs nothing. Constant logic needs like literal constant things. When you get to decider, this decision is usually if something, right? You have two choices now here. In the decider, you can either program, literally, if the player is nearby, do that, and this is the decider, or you can literally try, imagine yourself here in the game. You create a new, here in the project settings, input map, you create a new input map where you can control, you yourself can control something regarding an enemy with some sensors. So you add the sensors you think the enemy should know, say the distance from the player, what is the attack value of the player, whatever. You put a player, like your friend is playing, and you are playing some kind of enemy which follows this path, for example. And you yourself can decide whether to follow the path or not. You record your own inputs, or whether you like went up the path or went down the path, depending on whatever happened. And then you apply one of the simple models, which will essentially create you the if or else logic for you. This is how you can apply the simple version in the game. Of course, like following a path, maybe it's easier to implement the if and else. So decider, you can use machine learning, but it's probably easier to program yourself. Purpose, however, maybe it's like breaking even. Intelligent, if your AI is literally intelligent on what to do, machine learning is a very good proposition to give an interesting intelligent where even you yourself, the game developer, will be surprised on what will happen. Until intelligent, you can use the basics or intermediate versions of machine learning. To get to the player level, then yes, you need to apply the advanced versions because there are too many variables and too many possibilities of what to do. And this is where the techniques of reinforcement learning helps. This is the basics of machine learning. Look forward for the full video regarding machine learning, which I'll probably do in January, that's my guess. And how to use machine learning in Godot. It's probably, I'll put intermediate, I'll put say 11 neural networks. The simple ones, for some reason, they are ignored. I believe there is a asset or a plugin for neural networks. This would be considered an intermediate version, mainly because it's hard to make it work well, but I'll get to that in a future video. So I covered a lot today. Let me know in the chat or in the comments if you think I covered too much. I can break this video down in pieces. I have it in chapters already below for you to use the video properly. If you want more examples, I can also, if I split the video, I can give more examples in each of the segments, for example. Please let me know what you think, how I can make this better, how I can help you, the game developer, on understanding AI better and implementing a better AI for your game, and also making the AI in your game represent well your game and not just being a random thing that you're just copying from somewhere else. Because just as music, if you copy a music, then the players will remember the other game and not your game when the person like hears the music. Same thing will go to the AI. Yeah. And thank you very much for watching so far. Please like and subscribe if you want more things like this in your feed, and go enjoy the Godot Jam event.